Welcome back. And in question number 28, it says which expression is equivalent to x to the negative 6 power times y to the 4th power divided by x to the 3rd power times y for all x values and y where the expression is defined. Now, what we're going to do is there's two different ways that we can do this. I'm first going to show you the correct way, the way that we learned in class. And in this, if you notice, what we really have going on right here is division, right? So that fraction bar just means divide. So we can use what we call our quotient rule. Now remember that there was multiple rules that we had when we were solving these. And our 4 rules, we had the product rule, which says we add powers when multiplying. And then we had the quotient rule, where we subtract powers because we're dividing. And we had the power to a power rule, which means we multiply powers. And then we had the 0 rule, where anything to the power of 0 is equal to 1. And last of all, we had our negative exponent rule. Which says if we have an exponent and it's negative, for instance, if we had x to the negative 2, we can simply take that exponent and flip its position on the fraction, and it turns it positive. And vice versa. So those are all of our rules that we learned in class. And so on this one only uses, if you look at it, what we have going on right here, we do have things that are being multiplied, and we have division going on. So I'm going to go ahead and use our quotient rule to take care of this. So I'm going to start out using the quotient rule. So let me go ahead and write this down. We have x to the power of negative 6 times, I'm going to put the multiplication sign just to remind you that anytime two variables are sitting beside each other, they are being multiplied. So times y to the power of 4. And then in the denominator, we have x to the power of 3 times the power of y. So y to the power of 1, I should say. Now, in this case, notice there's no number there. But remember, when there is not a number there, the number is just 1. So it's really to the power of 1. So I'm going to write that on there because we're going to use this quotient rule. Now, our quotient rule says that we are going to subtract the powers, right? Anytime we have division, we're going to subtract the powers. So I'm going to rewrite this real quick. Over here to the right, I'm going to rewrite this as x to the negative 6 power minus, because we're doing some subtraction. Now, remember, the numerator is the power that always goes first, and then the denominator is the power that goes second. So minus, and this happens to be a positive 3. So I'm going to write in parentheses 3. Next, I'm going to deal with the y. So I'm going to go ahead and write my y, and I have to the power of positive 4 minus the power of 1. Now, if we want to go ahead and continue working on this, at this point, right, really just doing simple addition or subtraction. So let's go ahead and let's do this first one. Now, I'm going to put it in the calculator. I like writing it like this, and anytime we take the denominator's power, always put it in parentheses. If it has a negative in front of it, you would put a negative in a parenthesis with it. But because both of these powers in the denominator are positive, we just have a positive 3 and a positive 1 in there. I'm going to go to my calculator, and I'm going to first do negative 6 minus 3. I'm going to type it in just exactly how I wrote it. So I have negative 6 and then minus, right? So it was a negative 6 because it's the first number. But remember, if it goes in between two numbers, it then becomes a minus. So minus parenthesis 3, close parenthesis, hit enter, and it gives me a negative 9. So I'm going to write that down real quick. So I now have x to the power of negative 9. Now we got to do the y's power. So we have 4 minus 1. And I know there's some of you going, Mr. H, I can do 4 minus 1 in my head. I don't need to use the calculator. But I'm going to use it just for simplicity just to show you I'm putting it in exactly as I wrote it, and it gives me a positive 3. Now, if you're looking at this right now, I know what you're doing. You're saying, you know what, you just did the work, Mr. H, but none of the answer choices match. And the reason they don't match, it really boils down to the law that we had about negative exponents. So when we have an exponent that's negative, typically when we write our final answer, we always want to have a positive exponent in our final answer. We can't have any negative. Now remember, the rule says that when you have a negative exponent, you can just move it to the opposite position. In other words, if it's in the denominator, you move it to the numerator, it becomes positive. On the other hand, if it's in the numerator, you just need to move it down to the denominator. So I'm going to use this negative exponent rule, and I'm going to move this down as a denominator in the bottom. So I'm going to move it down. So let's rewrite this whole thing. So I have y to the third power, and then I'm moving this x down to the bottom. So now it's x to the ninth power, because we took it and we moved it down. So this is my final answer. All I did when I had this side by side is I took this one right here and moved it down as a denominator, and it made it positive. So let's go ahead and start ruling some answers out. I got y to the third, x to the ninth. So this is to the fourth and the second. Let's see, C says to the fifth and the third. This is the fourth and the ninth. So the correct answer is A, which is x to the third. Well, I'm sorry, y to the third and x to the ninth power. Now for those who are going, Mr. H, I have trouble memorizing these rules. This is not going to work for me. Let me show you a really easy way to get the answer correct without having to use these rules, or if you just want to double check your answer. So here's the second thing you can do. What we can do is we will write down our expression once again. So I have x to the negative 6 times y to the fourth over x to the third and y to the first. Now for the first, I'm not even going to put a 1 on there, because this method that we're using right here, we're going to call this one right here the guess and check method. And when we use the guess and check method, we don't need to put the power on there. This is going to be very simple. Now what I want to do is I want to assign a number for both variables. However many variables, I'm going to assign a number. But what we're going to do is, what you got to remember is, I want you to start with the number 2. And then after 2, you go to 3 and 4, and however many numbers you need, depending on how many different variables you have. Now in this case, we only have 2 variables, so we're just going to use 2 and we're going to use 3. Now I'm going to go ahead and I'm going to say 2 is going to represent my x variable, and 3 is going to represent my y variable. So I'm going to rewrite this real quick. This right here is going to be, I'm going to go ahead and put it in place of the x, I'm going to put a 2. So I got 2 to the power of negative 6. Put my fraction bar. And then for the denominator, it's x to the third power. So I'm going to put 2 to the third power. And then for my y, I'm going to put a 3. So I'm going to go ahead for the y. I'm going to put a 3. And that's y to the fourth power, so 3 to the fourth power. And for the y on the bottom, in the denominator, I'm going to replace it with a 3. And I'm not going to worry about putting a power of 1, because we're actually going to put this in a calculator and see what we get. So let's put this in a calculator. Let's see what we get, and that's going to help us find the correct answer. So control divide. And then I'm going to go ahead and I'm going to put 2. And I'm going to put to the negative 6 power. So caret key, negative 6. Then click to the right to get out. And then I'm going to put my next one, which is 3. So parenthesis 3. And to the power of 4. Then I'm going to click down and go to the denominator and put in my next 2. So I have another 2. That's an x value to the power of 3. Click to the right. And then another parenthesis and just 3 all by itself. So notice I got it in the calculator exactly as it's written here. I'm going to hit enter. And notice it gives me this odd fraction, right? 27 over 512, and that's fine. We're going to write that down. So I have 27 over 512. Now, all we have to do at this point is match this answer with the ones that we have here as answer choices. And let me show you what I mean by match the answer. So I'm going to get my calculator. I'm not going to write down another one. What I'm going to do now is just like I replaced the x with a 2 and the y with a 3 to get an answer here, I'm going to go back to my answer choices and replace the x value with a 2 and the y value with a 3. And I should get the same exact answer. If it is an equivalent, notice they have the word equivalent in here. If it really is equivalent and it was done properly, I should get the same answer for this value of a when I substitute 2 for the x and 3 for the y, as I did when I substituted 2 for the x and 3 for the y in this one that wasn't simplified. So let me show you. I'm going to go ahead, hit Control Divide. Notice our answer a, we have a y to the third and x to the ninth. So for the y value, I'm going to put a 3 because we use 3 for y. And notice it says to the third power, so I'm going to put the power of 3. And then for my x, it says x to the power of 9. So we use the 2 for the x to replace the x, right? So I'm going to put a 2 in there and to the ninth power. And I'm going to hit enter. And notice it gave me the same answer. Do you see that? So I know that A is correct. Now let me show you what it would have looked like if we used a different one. Let's say that A, it didn't happen to be the correct answer, right? That let's say that A was down here. It was where D is. So we needed to check some. Well, I'm going to go back and check B. B says x to the fourth and x to the ninth. So let me show you what would happen if we put in the wrong solution, the wrong answer choice. So we got 3 to the fourth power over 2 to the ninth power. And do you see how the numbers don't match? This has an 81 instead of a 27. So that would tell you that this one's the wrong answer. So when you're doing these, you have two different options now. You can either use the rules that you learned in class, or you can use the guess and check method. Find you an answer after substituting a number for each variable, but you do have to be consistent, right? Notice for all the x's, I replaced it with a 2. All the y's, I replaced it with a 3. And then once you get your answer, just substitute those same values into your answer choices and see which one gives you the same value. When you find it, that's it. Go ahead and pause this video and try to do number 29 on your own. Here on number 29, it says the tables of ordered pairs represent some points on the graph of two lines. Which system of equations is represented by the two lines? Now, they gave us a term here. They told us system of equations, and what I hope you remember is that we have some tricks that we can use in our calculator to help with systems of equations to solve this. Now, we have two different deals that we can do to this to solve it. First, we could convert these to slope-intercept form and graph them. That would be a way that's not too hard, in my opinion, to check. But the problem is you would have to check for A, B, C, and D, which means you would be converting all four answer choices. When I say convert it, in order to graph it, it must be put in slope-intercept form, which is y is equal to mx plus b. Right? So you have to convert both answer choices in each one. Some may be converted already, some may not. For instance, in A, right? This one's already converted. Y equals 5x minus 7. We can graph that. This one down here is not converted. We would have to convert it, and then we could graph both of them and check the tables and see if they matched. So convert, that's how we would do it by graphing. The other thing that we could do is that is kind of working backwards is they gave us two tables. So we could simply put these two tables in spreadsheet and get the two equations, graph them, and then after we graph them, we can see where they cross. And once we get that ordered pair of where they cross, we can use the system solver to check each one of these really quickly and determine whether or not it's the correct answer. Now, I think that's the easiest way. So why we could convert these and use them for graphing, and that would work. That'd be one way we could figure it out. I think what I'm going to do is go ahead and go over and just get two equations, graph them, find the intersection, and see which one of these matches. So I'm going to opt today for spreadsheet on this. Now remember, when we're using spreadsheet for this particular activity, we're going to be using menu 4, 6, 1 once we go into analyze. Let's go ahead and do that right quick. So let me grab my calculator. I'm going to go ahead and go home. I want to go down to spreadsheet real quick, right there, hit enter. And I want to go ahead, notice I don't have to delete it because I already have it deleted. It's only got one spreadsheet open. I'm going to change A to X. I'm going to change B to Y. And I'm going to put in the ordered pairs for each table. So let me start with the X values, right? So my X values over here in line 1 are -1, 1, and 5. So -1, 1, and 5. On the second column, right, for my Y values, I have -12, -2, and 18. So -12, -2, and 18. Now I'm going to click out of that box. I'm going to go home. I'm going to go over to data, hit enter. I do want to go down and change this horizontal axis to X, and go to the left and change my vertical axis to Y, and then hit menu 4, 6, 1. And there's my equation. So the first one is y equals 5x plus minus 7. So let me write that down. Y equals 5x. And it says plus minus. Remember, when it says plus minus, it really just means minus. Minus 7. So this is my first equation for line 1. And now what I want to do is I want to go ahead and find the equation for line 2. So let me find that one real quick. Now here's the neat thing. If you've already got this open and you haven't opened any other spreadsheets, you can actually just go back to the original and we can actually change these numbers and it'll change the equation. So I'm going to go ahead and put in the values in the X column for line 2, which is -1, 2, and 6. We already have a -1. I'm going to change that one to a 2 and change that one to a 6. And then for the Y values, I have 16, 4, and -12. So 16, 4, and -12. Now once I click out, I am just going to go back and click on 1.2. Notice my equation has changed. Let me move down here. I'll hold this and move it over. Alright, so now I'm going to write it down. So what we end up having here is we have y is equal to -4x plus 12. Alright, so now that we got this, this is line 1 and this is line 2. So I'm going to solve it using System Solver. So I'm going to write use System Solver, and that's going to be menu 3 and 2. And I'm going to write down my solution that it's going to give me. It's going to give me an ordered pair. I'm going to have an x value and a y value. So let me go and get my calculator and let's do that real quick. So I'm going to go home. I'm going to go up to calculate, hit enter, and I want to go ahead and type it in real quick. So menu 3 and then 2 for System Solver. It says you're going to have 2 equations. That's correct. In Algebra 1, we always have 2 equations. I'm just going to hit enter for OK. And I'm my top equation in the top box and my bottom equation in the bottom box. And I'm going to put the whole thing. Y equals 5x minus 7. And then I'm going to put my second equation. Y equals -4x plus 12. And I'm going to hit enter. So notice it gives me these two fractional values, right? 19 over 9 and 32 over 9. I'm going to write that down. I'm not going to worry about converting it. We don't need to. So 19 over 9 and 32 over 9. Now, what's important is because this is my solution right here, if I check all the systems that they have for answer choices, for instance, A, B, and C, and D, one of these systems, when I put it into the calculator, is going to give me the exact same values. And when it does, I know that's the correct answer. And that prevents you from having to go and to convert everything to y equals mx plus b and match it with these two equations. But if you feel that it's easier just to go and to move this 4x over to the right and then divide out the -1 on both terms, that's the way I would do it. But if you feel like that's hard and you like using a calculator, well then just do the trick that I'm doing right now. So let's start checking these to see which one of them is going to give us 19 over 9 and 32 over 9. So I'm going to go ahead and go to System Solver. Again, we're going to go Menu, and I'm going to go 3 and 2. I'm going to hit Enter, and I'm going to go ahead and type in this first one. So the first one, we actually have y is equal to 5x minus 7. And then on the next problem, I have 4x minus y equals 4. Now notice this gives me 3 and an 8. So we can go ahead and use a strike through. That is not correct. So it's not A. So we're going to try B now. So Menu 3, 2, hit Enter. And let's go ahead and put in y equals 5x minus 7. And I believe it's going to have to be this one because we already know one of our equations was y equals 5x minus 7. Notice that the other two have a negative, have a 7 here and a 7 here. So I'm actually going to strike those out. Those, they don't have, one of the equations is wrong already. I really believe it's just going to be this one up here. Because notice in the bottom ones it had a 4. So let's take a look. I'm going to put in my second equation, which is 4x plus y. So 4x plus y is equal to 12. And I'm going to hit Enter. And notice it gave me the same answer. 19 over 9 and 32 over 9. Right? And that's what we had right here. 19 over 9 and 32 over 9. So we know that B is the correct answer. Now, just hang tight. I know I said I was done, that I wouldn't do the conversion if I didn't feel comfortable with it. But because there's some of you who like doing a convert, I want to show you how we could have found this same answer. Let's face it, B already had the top equation written in slope-intercept form. So we already knew that it either had a or B because we had already gotten y equals 5x minus 7 when we put that table into our spreadsheet and converted it to a slope-intercept form equation. Now I'm going to go ahead and I'm going to get B. The one that we weren't sure about was the equation on the bottom, right? 4x plus y equals 12. If we would have done that by hand, so I'm going to write here, by hand, then what we would have done with that, we would have had 4x plus y equals 12. Now if I want to move this, if I want to solve this and convert it to y equals mx plus b, our slope-intercept form, I would have went ahead and I would have subtracted 4x from both sides. I'm going to draw a line through my equal sign, subtract 4x over here. This over here becomes a 0 set, so it cancels. All I'm left with is simply y is equal to, and notice because this is a variable and this is a constant, we can't put it together. We simply bring down our variable. We always want to put it first. And then we take our constant, which in this case happens to be a positive 12. And I know it's positive because there's no negative sign in front. And I would just bring it down at the end. And then I would just check and see, does this match what we got when we use spreadsheet to find the equation of the table? And it does. Notice they match each other. So this just confirms this is definitely the correct answer. If we would have done A, we would have got a different equation once we converted it. So that's two different ways that you can solve one of these. Do the way that makes most sense to you. Pause this video now and move to the next problem and see if you can get it correct. Here on number 30, notice it says a function is shown. What is the range of the function? So they're asking us for the range, so we have to go back and make sure we understand the difference between domain and range because we're going to be looking at some things on a graph. So I want to go ahead and just give you a little bit of information. First of all, I'm going to go ahead and draw this out. When we talk about range, range is how far we go up and down. on the y-axis. So in other words, this in black, it would be a y-axis because it's vertical and runs up and down. On the other hand, sometimes these problems will ask for the domain. And the domain is in regard to the x-axis. And when we talk about domain, we're really just speaking of how far do we go to the left and how far do we go to the right. So I just wanted to clarify that. When we talk about the y-axis, we're talking about y values. So range is all about the y values. When we talk about the x-axis, we're talking about our x values. So domain is all about the x values. Now I think when we have something like this where all they've done is given us in a function, what we need to do is put that in a calculator and graph it so that we can see what it looks like, and then we can make a determination on what its range is. So I'm going to write right here, you want to graph it. So let's get our calculator and let's graph this function. I'm going to bring this over here. I'm going to go home. I am going to go to my favorite graphing feature, and on this, my favorite graphing feature is actually to go home and go to the one on the bottom. I like it because it automatically opens the tab up for you to be able to put in your function. Notice it says f of x. So I have f of x is equal to 2 over 5. I already got f of x is equal. So all I got to do is start with my fraction. 2 over 5. And then I'm going to put a parenthesis. And then it says x minus 25. So x minus 25. Close parenthesis. And then it says squared. So put a square symbol. And then plus 13. Notice it looks exactly like what we have on the paper over here. Right? All of this matches right here. And so what I'm going to do now is I'm going to hit enter, and we're going to get to see a picture. So notice it didn't pull up. I'm going to hit menu, go down to Windows Zoom, and I'm going to zoom out. So I'm just going to zoom out until I can see it. And there it is. We can see it right here. I'm going to hit escape so that we don't zoom out anymore. Now, when it asked about the range, I want you to remember range, right, is up and down. So I want to see how far this parabola goes up and down. Now, I can tell you right now it has a minimum because it opens upward. So what I got to do is I got to figure out what is this y value right here, because that's the furthest it goes down. That's going to be my low end of my range. And so what I'm going to do is I'm going to try to figure out where that is exactly. And I'm going to use menu, analyze graph, and I want to find my minimum. Now if the parabola had been flipped upside down, I would find my maximum. But because it's flipped up, I'm going to find the minimum, and it's going to tell me how far it goes down on the y-axis. I'm going to hit OK for my lower bound, drag it to the right, and hit OK for my upper, and there is my vertex, or what we would also call in this case, because it is opening up, our minimum value. Now the y value is the second number. So I'm going to write this down real quick. Notice in the ordered pair, I'm going to write minimum. This is my minimum right here. I need you to remember that the first number is always x, and the second number is always your y value. So this is actually at 25 and 13. So what that means is my minimum is 13. So my graph goes as far down as 13, and because it's a parabola, it goes up forever, right? Infinitely. So if I wanted to write this as an inequality, knowing that it goes as low as 13, and I'll just sketch a picture here. So that point right there on that line is 13. I would go ahead and say that y would need to be greater than or equal to 13. Now I'm just writing this out because this is kind of help me with the verbal statements. I personally have issues with reading, you know that. I've told y'all many times, and so I like to write it out as inequality first and then try to see what makes most sense. So let's look at A. We're going to start striking stuff out. A says all real numbers. Now all real numbers would mean that it goes forever down and it goes forever up. And that is definitely not the case. So we're going to strike that one out. Because remember, it doesn't go any lower than 13 according to the picture in the calculator. That's the lowest it goes. This was our minimum value, or our vertex. Next says all real numbers greater than or equal to 25. Well, that's not true. 25, right, that has to do with the domain. It doesn't have to do with the range, which is my y values. So it's not going to be B. C says all real numbers greater than or equal to 10. Well, that's not true. 13 is greater than 10. So that's false. And D says all real numbers greater than or equal to 13. That is absolutely true. It can touch 13, and then it can go up to any number above that. So I'm going to go ahead. We have found our answer. D is the correct answer. It is all real numbers greater than or equal to 13, which is what we have here. Y represents all values on the y-axis that are greater than or equal to 13. Here in problem number 31, notice we're talking about causation and association. So I just want you to think about a few things. When we talk about causation, remember we had a discussion and we talked about thinking about it in terms of cause and effect. So whatever happened in the beginning, right, created the situation in the end. Now, when we talk about association, remember in that case, we're just saying that there's something that relates to one another. So for instance, I'll just give you an example. We have a few different types of association. We have linear and nonlinear, and we also have positive and negative. So let me draw some examples for you real quick just to refresh your memory. I'm going to do a linear association, and I'm going to do a nonlinear. I'm also going to make one strong and one weak. So if this was a strong positive linear association, what we might see is something like this. Some points that look like they follow a line really closely. A few of them might be off, but they're really close to following a line. This would be a strong positive linear association. Now if it was weak, the points would be spread apart further. If it was negative, then it would trend down from left to right. But because it's positive, it trends up from left to right. So that means that there's a pretty close relationship between our two values, our two variables, our bivariate data, which is x and y. Right? This being the x-axis and this being the y-axis. When we talk about a negative nonlinear association, right, it's the opposite of positive, because what's going to happen is on this one, right, with the positive, as x increased, y increased. So as we move to the right, it moves up. Move to the right, it moves up. When we talk about negative, it's going to be the opposite. As we move to the right, it's actually going to move down. So if we had a negative nonlinear, it could be something like this. Draw my points. Notice my points are a little further apart. They're not as tightly knit together and grouped, and you have a curve that's going on. It starts up here and then it drops down and starts to flatten out. So this is nonlinear because if you were to take a pencil, right, you would find that there's a curve in the data. There's a point where it kind of curves and then starts to flatten out. This is negative because as I move to the right, my values begin to decrease. So as x increases, the y values decreases. That being my x-axis and that being my y-axis. So when we talk about association, we say, can the two things have a relationship? So I would say with causation, we're going to say for certain what occurred first caused what occurred second. For association, we're just going to say, do they have some type of a relationship? Maybe it didn't actually cause it, but it seems to be something that trends with it. And I'm going to give you an example here. Let's take a look at these two question types. And the first one says, as the outside temperature in degrees Celsius increases. So that means it's getting hotter. as it gets hotter outside, the number of minutes it takes for a bowl of ice cream to melt decreases. And that would be true, right? This would be association and causation. Causation because when it's hotter outside, your ice cream is definitely going to melt faster, which means it's going to take less time to melt. So we're going to say this one is both association and causation. Now let's look at the next one. It says as the sales of winter coats increase, the outside temperature decreases. Now some of you may look at it and go, this makes sense. When it gets cold, we go and we buy coats. But I want you to think about it. What caused the buying? So is the buying of coats, did it cause the weather outside to get colder? Or was it that the weather outside got colder and it caused people to go buy jackets? And so in this case, because of the way it's written, it talks about as the sales of winter coats increases, the outside temperature decreases. We know that the sale of coats cannot change the temperature. So while you might be tempted to say it's causation, this is not causation. You can buy all the winter coats you want, and the temperature outside is not going to change and get colder. But it could be an association. So I'm going to say association only because typically you're not going to be buying winter coats in the middle of the summer. So this one right here is only association. Now if they had no relationship to each other, let's say this was swimming suits and the outside temperature decreases. In that case, I would say it's neither association or causation. But because we do know that people do use coats in the winter, I would say definitely if you have an increase in sales in coats, it's very likely that the temperature has dropped. But the selling of coats increasing did not cause the outside temperature to drop. Go ahead and pause this video and now try to do the next problem on your own. In this problem, it says dance lessons are offered at 2 studios. The cost of dance lessons at each studio is shown. Studio Q charges a $30 registration fee plus $80 per month. Studio R charges a $105 registration fee plus $65 per month. After how many months will the total cost of dance lessons be equal at the 2 studios? So we're talking about total cost. Now, a couple of different things. I hope that you can see when we're looking at this with these 2 different situations, we have 2 different equations. And if you got 2 different equations that you're going to put together and use to determine a point at which there'll be equilibrium, or where 2 things will kind of meet together, we call that a system of equation. So let's go ahead and look at our 2 scenarios. I'm going to write them first. First, we're going to start out with Studio Q. So we want to write an equation based on this scenario for Studio Q. Now it says that there's a $30 registration fee plus $80 per month. Now I want you to remember that when you have keywords such as each, every, and, or per, that represents slope about 98% of the time. So they're telling me that that's a unit rate or a slope. On the other hand, they have a one-time fee of $30. Anytime something just happens one time, like it's the initial fee, it's the down payment, it's where somebody started. Any type of one-time event that costs money or has some value assigned to it is going to be your y-intercept. This is important because we have to be able to write this equation. So remember this right here, when I say slope, it means it's going to represent the letter M. And when I say y-intercept, it's going to represent the letter B. So I'm going to write the equation for this first one. We have y equals, and they said it's $80 per month. So the M is going to be equal to 80. And then it said there was a registration fee of $30. Now registration just means it happens one time when you sign up for it initially. So I'm going to put a 30 right there. And when we write our equation, we're going to write it in the form of y equals mx plus b. So therefore, I'm going to replace the m with $80 that occurs every month. And I'm going to replace the B with our registration fee, which happens one time. And this is the equation I'm going to be using for my system. Now, we still have another one that we got to deal with, right? That was just the first one. So now we have Studio R. So I'm going to write that down, Studio R. It says that we have a $65 per month fee. So I know that my M for that one is going to be $65 per month. And then it says it has a $105 registration fee. So that's my B value, $105. So when I write my equation is going to be Y is equal to 65x plus 105. So there's our second equation. Now the wonderful thing is we have two equations and we can go ahead and use them to find some information. On the other hand, we do have a dilemma here, right? Because notice we're going to get an ordered pair if we solve this system. So I'm just going to write the ordered pair right in the middle of them because it represents both equations. And we're going to have an x value and we're going to have a y value. But what we haven't talked about yet is which one of those values represents what they're asking for. Now what I would tell you is x is always what we call an input, right? So like go all the way back to 7th grade math, 6th grade math. X is an input. Y is what we call a output. So another way that they talked about this in earlier years is that X is not only the input, but we also call that the independent variable, while Y is the output, and it's the dependent variable. So something is going to occur, that's our X, and it's going to create a certain amount of cost, that's our Y. Now I want you to notice when it said after how many months, I'm going to highlight that a different color. Will the total cost of the dance lessons be equal at the two studios? Okay, so X is our input. So what makes a difference on what the cost is? Well, it's how many months occur. The more months occur, the more cost occurs, right? It's like your phone bill. Think about it. When you have your phone, if you only have a phone 1 month, you just pay 1 month's value, right, or cost to have that phone and use it. And if you had your phone 6 months, the cost would be higher. Why did the cost get higher? Because now you've paid 6 months worth of phone bills instead of just one. So I know that X, and X is usually going to be time as well. It's very often it's going to be time or sequences. So X is going to be the time, which we call in months, and Y is going to be our total cost. It's what we are trying to measure. So when we put these two equations in our system solver,
we're only going to be looking for the x value, not the y value at this point.
Now I want you to remember to get to system solver, I'm going to write it right here, system solver, you're going to go to menu 3, 2, and calculate. So let's go and get the calculator real quick, and we're going to type these in. So I'm going to go home, and now that I'm home, I'm going to go up to calculate, and I'm going to hit menu. I'm going to go down to 3 for algebra, and I'm going to go down to 2 for system solver, hit enter, and I'm going to type in my first equation. So our first equation is y equals 80x plus 30. And then our next one, the second equation, is over here, y equals 65x plus 105. So now that I got both equations in, I'm going to hit enter, and it gives me 5 and 430. So I'm going to write that down. 5 is my x value. That's the months that have passed by. And 430 is going to be my y value. That's the cost. So when it says after how many months will the total cost of the dance lessons be equal at the two studios? Okay, so I want to know how many months. It is asking me for the x value. So at 5 months, that's when the total cost is going to be the same, which is $430. So I'm going to go ahead and pick A for my answer. Notice 280 it's a cost. Not sure how they got that calculation. 9, that's an amount of months. 430, that's how much it cost at that time. But they didn't want to know the cost. They said, after how many months will the total cost of the dance lessons be equal at the two studios? They wanted to know how much time would pass by. Now, I do want to show you, we could also graph this if we wanted to. And you could graph these two equations and find where they cross. You would have to do some zooming out. But you know what? It's worth taking a look. This would be one since you had the equations. We wrote them both in slope-intercept form. It is a good one that you could use for graphing. And I do want to go ahead and just show you what that would look like. So I'd put in my first equation, and I would put in 80x plus 30. And then I could go ahead and graph the second one by hitting tab. And we'll put in this one on the right, 65x plus 105. Hit enter. And you can't really see where they cross right here, but what we could do is I could go ahead and go to zoom and out, and we can zoom out pretty far. Now you might be looking at going, Mr. H, I can't see where they cross. Well, that's okay. We're just going to hit menu. We're going to go down to analyze, and we're going to find intersection. The calculator can see it. I'm going to move this over on the left, click on it, drag it to the right, click on it, and I want you to notice that it gave me an ordered pair. So I'm going to put my hand on it, hold it down, bring it up, and notice, even though we really can't see the intersection, we'd have to zoom in at 430 exactly on the y-axis to be able to see it. Notice it is telling me that it crosses at 5 and 430, which is the same thing we got when we used the system solver. It's just another method that you can use if you wanted to double check it. So you know what your correct answer is. Pause this video and now try to do 33 on your own.